So today we're going to talk about the star method. Let's set up a little template for it and explain what the parts mean. Then we're going to work two problems with it. So please write all this down on your frame. So first, it's called a star because we're starting with an X with a line through it just like this. As we talked about yesterday, we have ax squared plus bx plus c. A is going to go here. A is also going to go over here. AC goes up here. When two variables are next to each other, what does that mean? Multiply. So we're going to put A times C up here, and then we're going to put B right here. And then we're going to do some other stuff which is actually similar to what we did yesterday, and I'll show you how to fill this out and then take this and turn it into your 2 binomials. So the first example we're going to do with this, example 1, is going to be 3x squared plus 17x plus 10. Right? And pay attention. So here we have A equals, what does A equal in this case?
3.
3. B equals
17.
And C equals 10. Okay, so now let's take this and let's draw our little template. And I'm going to go ahead and put A, AC, A, and B. And I want you to, on your homework, I want you to continue to label these. So what does A equal in this case? 3. So I'm going to put a 3 here, and I'm going to put a 3 here. What is A and C? 3 times 10, which is
30.
So 30 is going to go right there. And what is B?
17.
17. So 17 goes right there. Now, this is where it gets sort of similar to what we did yesterday. Because we're going to ask ourselves, what multiplies to equal 30 and adds to equal 17? Again, multiplies to get 30, the A times C, and adds to get 17. Let's just list some factors of 30 and see if they add to 17. So 1 times 30, is that 17?
No.
15 times 2, is that 17?
Yes.
It is, so we don't have to go any further because 15 plus 2 equals 17. Now, what we're going to do with these numbers is a little bit different than what we did yesterday. So these numbers we're going to plug in right here. And it doesn't matter where either of them go, just one goes on this side and one goes on that side. It's perfectly fine if you put the 2 here and the 15 there. It doesn't matter. Okay, so now once we have these numbers, we have to see if we can simplify this anymore. And so we're going to be looking at this fraction. Can I simplify that fraction?
No.
No? Can I simplify this fraction?
Yes.
I can. What is this simplified to?
1 over 5.
1 over 5. So you do need to simplify it. So this is going to be the one we're going to end up working with. Now you don't have to do this next step either, but sometimes if you go ahead and just put a little x right here and put a little x right there, it's not a bad idea. Then this goes in one parentheses, so this becomes x plus 5. What's going to go in the other parentheses? 3x plus 2. So the numerator, when it's written like this, what's on the top goes in the front, the denominator goes behind it. Same here. Now, just like yesterday, we can check these to make sure we're getting them right. So I'm going to go ahead and put a box around my answer, but I'm going to check it to make sure. And so this is going to be x plus 5 times 3x plus 2. X times 3x is? X times 2 is 2x. 5 times 3x is
15.
And 5 times 2 is 10. Combine my like terms. 3x squared plus 17x plus 10. Did it work?
Yes.
It did work. So did we get it right?
Yes.
You did. Now, if things don't come out right, sometimes you can put numbers in the wrong place or something like that. You'll catch that. Or if you forget to reduce, you're going to have, your numbers aren't going to work out either. And oh, okay, I got to go back and reduce. So think about those things. Are there any questions about this before we do the next example? Okay. Does everybody have this written down so I can erase it? Okay. Let's go ahead and flip over to the back of the frame now.
If you had,
Yes, sir.
can you still do this for the second method, the when A equals 1, could you still do it?
You can still do it this way.
Alright.
What would that become?
Okay, let's do, I call this example 5 because we had 4 examples on the other side. And to answer Isaiah's question is, yeah, it's a little more work. If you see the other way, you can just go straight to it. But if you're not sure, this way always works. So, in this case, what does A equal?
3.
What does B equal?
-11.
-11. What does C equal?
-20.
-20. So let's go ahead and make our star. Remember, this is A, this is A, this is AC, and down here is B. A is 3 and 3 again. AC is -60, and B is -11. So, they're going to multiply to get what number? -60, and they're going to add to get -11. In order to multiply to get a negative number, what's true about the signs of those two numbers? They're different. One's positive, one's negative. So, let's just think about things that multiply to get 60. We have 1 times -60. Nope, that's not going to get us this, right?
30 times -2.
What?
30 times -2.
Okay, so -2 times 30. Those aren't going to add to get that either. 5 times
6.
-12. That's not going to get us -11. What am I missing here? I skipped a lot, by the way, on purpose.
11's the right number.
Let's go.
15 and -4.
Okay, well, so let's. We could have gone 3 and -20,
Oh, yeah, negative.
and then 4 times -15 adds to get -11. So these numbers, again, are going to go right here. So I'm going to put my -15 right here, and I'm going to put my 4 right here. Now, this one can't be reduced. But can this one be reduced? What is this reduced to? 1 over -5, so that's the one we're going to use. Remember, the numerators are the top is the x. So this becomes x minus 5. This one is 3x plus 4. And let's go ahead and check it. So we have x minus 5 times 3x plus 4. Distribute 3x squared plus 4x minus 15x minus 20. Combine those like terms. Did it work?
Yes.